In this video, we're going to build a local research agent with Python, Ollama, LangGraph, and Streamlit. The large language models are extremely powerful, but if you do not provide them with the right information, they're just going to make up their own information or even worse, hallucinate. And providing the correct information or context engineering is even more important if you use local models because they are way smaller than commercial models. Now, in the past, I've made multiple videos where we use retrieval augmented generation to provide this context to the large language model. Now, retrieval augmented generation, or RAG, is a really powerful technique if you want to build an AI agent that can answer questions about a really narrow topic. Now, the research agent that we are building in this video is able to answer questions about almost any topic because it's able to perform its own research using Google. Now, the aim of today's video is not only to build a research agent, but also to introduce you to one of the most transformative frameworks for building AI agents, LangGraph. And to be completely honest, when I started learning LangGraph, I found it quite intimidating. And that's because LangGraph introduces a new paradigm to build AI agents, which is way different than other frameworks like LangChain, for example. And that has everything to do with nodes, edges, and with this graph. And if you feel a bit intimidated by LangGraph as well, this video is for you. So in this video, I'm going to start with a really simple example to show you how LangGraph works. Then we're going to integrate LangGraph with Streamlit. And at the end of this video, we're going to build a research agent that uses Google to answer all your questions. And I promise you that if you watch this video till the end, you're going to feel like you've been building agents with LangGraph for decades. Before we dive into the code, let's take a look at what LangGraph actually is, why it is different from LangChain, and why this framework is so important if you want to build reliable AI agents. So what you see here on my screen is the design of the research agent that we're going to build together in this video. So within LangGraph, there are three types of components. There are nodes, and nodes, these are basically where the action is taking place. Then there are edges, and edges are basically the transitions between the nodes. So for example, here you see that in this node, research is performed, and then you see that there is an edge to transition to the other node where a conclusion is then being written. And then the third component in LangGraph, those are conditional edges, and this basically means that within the node, a large language model in most cases is making a decision to which nodes to transition. So let's take a look at the design of this agent. So after every question from the human, we are starting here at the start node, and then we are transitioning to this conditional node, research needed. And this node decides whether research is required in order to answer the question from the user. So just imagine that the user is just asking the agent, how are you doing today? So in this case, the agent doesn't have to do any research. It can just answer it, hey, I'm doing well, how are you? So in case no research is needed, we're going to transition with this edge to the answer question node. And this is just a large language model answering the question of the user. And then we're going to transition to the end node where we're going to provide this answer to the user. So in case research is needed, so let's just imagine that someone is asking, what is LangChain? In that case, the agent has to do research because the model doesn't know this by itself. And we're going to transition to the right Google query node. Now, the right Google query node has one large language model packed, and that large language model has only one task, and that is to create a Google query based on the question of the user. So if the user is asking what is LangChain, then a good Google query would be LangChain explanation. Then this query will be provided to the next node, which is perform research. And this node can only perform one action, and that is to send the Google query that was created in this node to Google and then fetch back the result. After the result is being fetched, the result will be added to the memory of the agent, and then the agent will transition to the next state, which is write conclusion. So the write conclusion node has only one task, that is to take the Google query, the research question, and the research, and based on that, write a conclusion that is answering the question of the user. Then as soon as the question is being answered, we also want to do a check whether we are actually answering the question of the user. Now this node, which is a conditional ask, will do only one thing. It will take the question from the user, it will take the conclusion, and it will check whether the question of the user is answered with the conclusion that is being written by the large language model. And if the question is being answered, we are going to transition to the end state, If the question is not being answered, we're going to transition back to write Google query. We're just going to write a new Google query, perform research again, etc., etc. And then here we're going to check again whether now the question from the user is being answered. So why is LangGraph such a valuable framework? So of course you can put agents on some kind of a spectrum where this is a fully autonomous agent and this is an agent that has a very small level of control. It can basically only say yes or no. So of course if you want to build an agent with a really low level of control, it is really easy to build such an agent and this agent will be really reliable. But the problem with most agents lies here, because if you build agents that are quite autonomous, it's really difficult to build applications that are reliable. So as soon as the degree of autonomy increases, the application reliability goes down like this. And that's exactly why LangGraph has been developed, because what you see here is that when you build a very simple agent with a very small level of autonomy, it doesn't really matter if you use LangChain or LangGraph. But when you start building agents that are more autonomous, LangGraph can make these agents more reliable. And LangGraph is actually a very small framework, and it has only two main components. First of all, states. And states basically means everything that we have seen on the previous slide. So we have seen nodes, we have seen edges, conditional edges, etc., etc. This is all part of the mechanism that manages the state of the agent. And the second component that is really important in LangGraph is the graph. And the graph basically keeps track of all the information that has been gathered by the agent. So you've seen in the previous slide that we started writing a Google query and then we performed research. So all this information is gathered in the graph and is being transitioned between the different nodes. Okay, so what is the big difference between LangChain and LangGraph? Because in most cases you will use them together. LangChain is basically providing all the components, the large language models, the vector stores, the retrievers, etc., etc. And LangGraph is basically providing the application logic, the orchestration. So LangGraph is making sure that you have all these different nodes and that you have a mechanism from where you transition from one node to the other node. So again, in most cases you will use them together because you need the components from LangChain and the application logic from LangGraph. Okay, so before we dive into the Python code, let's take one more look at the ecosystem. So there is LangChain, which is the name of the company, and as well the name of the library that provides all the components, like the standard building blocks for building agents. Then there is LangGraph, which is basically providing the application logic for building reliable AI agents. And then there is LangSmith, which is a platform where you can basically see how your system is working, and you can basically use this information in order to improve your agent. Then there is LangSmith deployment, and this was formerly LangGraph platform, and this is a platform where you can deploy your agent. And LangChain and LangGraph, these are basically open source and free components, but LangSmith deployment, this is basically the commercial side of the company, which is actually making the money. Then you have LangSmith Studio, which was formerly LangGraph Studio, and this is a visual studio that you can use in order to build AI agents. Okay, so this all looks very promising, so let's take a look at how this actually looks in Python. As you can see, I'm importing the LangGraph library here, and then I create a class here, and this class is of type dictionary, and as you can see, this dictionary at this moment has only one element, which is a string called graph state. And in this very simple example, we are going to store all the information of this AI agent in this string. If you have larger AI agents, this dictionary normally contains more items. So you will see that in the next script. Then you see, once we have created the state, we are going to start with the creation of the nodes. And the nodes are the circles that you have seen in the previous slides. So as you can see here, I have three nodes. I have start node, I have happy node, and I have a sad node. So the start node will always just add to the graph state I am. And then you will see here that the happy node will say I am happy, or will add happy to I am. And the sad node will concatenate sad after I am. So those are the three nodes. And then where the actual logic is taking place in this AI agent is in the edge. So you see here that there is also one edge, which is decide mood, and this edge will decide on the moods. So 50% of the times the AI agent is going to be happy, and 50% of the times the AI agent is going to be sad. So you will see that we have created three nodes. We also have one edge, one conditional edge. And the first thing that we are going to do here is building the graph. And the graph is actually some kind of executable of this AI agent. So we are going to take everything, the nodes and the edges, we are going to put it all in the graph. And then we're going to compile this graph in some kind of an executable. So you will see here that we are initiating the graph, and then we are just adding all the nodes to the graph. So this is really simple. You see here, if we refer to start nodes, then we are referring to this actual function, etc., etc. So that's everything that we do here in building the graph. Then you see that we are adding the edges, and you see that there is one conditional edge here. So in that case, you add a conditional edge, and you will see that the conditional edge is basically positioned between the start node and the conditional edge is called decide mood. So this is referring to the function where the conditional edge is taking place. And then you see here that the function returns either a happy node or a sad node. And this is then referring to happy node or sad node. We're just referring to those two nodes. So once you've added all the ingredients of this AI agent, so first of all, you have initiated all the nodes, then you have added all the nodes to the graph, then you have added all the edges. So then we basically have this AI agent, and then we are just going to compile it to a graph. That's what we do here. And once we have compiled the graph, the only thing that we have to do, this is like 100% the same as what we also do in LangChain. We're just going to take the graph and we are going to invoke it. And of course, we are going to provide it the arguments that it needs. In this case, we have a dictionary with only one element, graph state, and in this case, it is empty at the start. But of course, you can also provide arguments here so that the graph already has an initial state. And then you see here that I print mood graph state. And if I run this script, you'll see here that the start node is running, the set node is running. So what you see here is just, those are just like print statements. So it's not actually adding anything to the logic of the agent, just to visualize the route of the agent. And then you will see that the outcome of this AI agent is I am sad. And if I run this agent again, in this case, the AI agent is happy. So this is the basic architecture of LangGraph. I hope you now understand how it works. But in this really simple example, we are not really using large language models yet, which we are going to do in the next example. Okay, so that was a very good foundation, but in most cases, when you want to work with LangGraph, you actually want to work with a large language model. And you also want to integrate your AI agent in some kind of a user interface like Streamlit, for example. So in this script, I'm going to show you exactly how to do that. But before that, let's head over to our .env file. So as you can see, by default, I've configured this AI agent to be able to work with Ollama and with the Llama 3.2 model. If you want to work, for example, with an OpenAI model, you can just comment out these lines, make these lines visible. And the only thing you have to do is to add your OpenAI API key. And for those who are new to Ollama, I'm going to show you how you can install the Ollama application to run models locally on your PC, and also how to run this large language model on your PC. So for that, I'm going to head over to the ollama.com website. Then we're going to click on download in order to download the application. I'm going to download it for Windows. And then you can just click on the executable in order to start the installation process. Just navigate through the installation process. Now, while the installation process is still ongoing, I'm going to navigate to the website, then to models, and here you can find all the models that you can run within Ollama. And a model that I really like to work with is this one, Llama 3.2. And so you just click on the Llama 3.2 model, and within this model you can choose between two variants, because there is a 1 billion and a 3 billion parameter model. The 1 billion parameter model, you can use this model if your PC isn't that strong. And if you have a bit of a stronger PC, you can use the 3 billion parameter model. Both models should be able to run on almost any PC, but if your PC is not that powerful, it's just going to take a while to generate a response. So I'm just going to click on the 3 billion parameter model. And then you can just copy this command, copy. Let's see how far we are with the installation process. You see that Ollama is now installed on my PC, and I can talk to the models here. But of course, we want to talk to Ollama and to the LLM from our Python application. So I'm just going to open a terminal, and then let's make sure that we also install the model. So just paste here Ollama run Llama 3.2 to 3b. I already have this model installed, but if you haven't installed this model yet, it will install the model for you. So let's run it. As you can see, I cannot talk to the model, so I can now say something like, hey, how are you? And the model would then respond. Okay, so if you are able to chat to the model, this means that the model has been installed. And then I'm just going to navigate back to VS Code. And here you see that I start again with importing a lot of libraries. You see that I am importing those two libraries. So in a chat model and all the messages like the system message, the human message, and the AI message. These are all components from LangChain. Because LangGraph doesn't have these components itself. So anytime you would like to work with LangGraph, you also have to work with LangChain or with a library which is similar to LangChain. And then you see that I import load.env and as well Streamlit, as I want to build this graphical user interface. Now, this is where we are basically initiating a variable, and this variable is going to keep track of all the messages. I've explained this in some of my earlier videos. So first you're going to send the message, how are you? And the AI is going to say great, and then you're going to send the next message, etc., etc. So this variable is keeping track of this entire chain of messages. So it's really important. And what we are doing here, so the Streamlit application is refreshing all the time. So here, this is basically loading the messages from the memory, and this is then putting the messages on the screen. So it's going to give a different color to the user message and the AI assistant message. You're going to see that in a second. And then this is where I'm actually initiating the large language model. So you see that this is all coming from the .env file that we have seen earlier. So you can there configure the chat model, the model provider, which can be Ollama, OpenAI, Anthropic, etc. And as well the model temperature. I've as well told in some of my previous videos about the model temperature, so I'm not going to do that again. And then the system message is just something like, you are a friendly chatbot, engage in a pleasant conversation with the user. Then this is where I'm initiating the state object. And here you see that we do not just have a string, but we have a list with messages. So this object is keeping track of all the messages within the LangGraph graph. And then you see here that we only have one node. That's the node chat. So you see that we are invoking here the system message, and we are adding all the messages that we have saved in the state. And at the end, we are going to provide back all the messages, but we are adding the message that has been generated by the AI model. And that is the large language model that we are invoking right here. So if you've worked with LangChain, I think this looks quite familiar. And this is just to send the result of the large language model back to the graph. Okay, then what you see here, so we are initiating the graph. We are adding the edges, so we are navigating from start to chat and from chat to the end. We have only one node, as I mentioned, and then we are compiling the graph so that we can execute it. Now this logic, I'm going to start Streamlit because I want to show this in action. So we're going to type Streamlit, run to tab like this, press enter, and then this will initiate the Streamlit application that we have built here. So you will see that the Streamlit application has a title. You see that's the one that you see here. And here you see this is where we can actually ask our question. So I'm just going to ask, how are you? And you will see that we get the user question in red and then the response from the AI model. So this, what you see here, this is coming from, let me just minimize this one a bit. So this bar is coming from here. So if prompt is stchat input, that's created here. And I see here that we're going to take the user message. We are going to save it as a human message to show that this is a human message. And then we are going to append it to the Streamlit memory. And that is the object that we have created right here, right? So we are just appending this message. And then we are putting it on the screen, and this makes sure that we are putting it on the screen as a user message. So this is basically this part. Okay, so we have put the user message on the screen right here. And then this is where we are going to invoke the agent. So because we have compiled the graph, we can now just invoke the graph. So we're going to use graph.invoke, and then we're going to provide the parts of the graph that we want to provide as arguments. For example, we're going to provide the messages, and the messages are coming from the Streamlit object. So we are invoking here in response, and then we are writing the basically the last message. So -1 is referring to the last message. We are putting that on the screen, and then we are appending as well the response from the AI agent to the Streamlit memory. So let's just ask something like, what did I just ask? Just to see if the memory is working as expected, because by default large language models do not have memory. They can only get like one message at a time. But you see here that the LLM knows what it's talking about. You asked how I am, you wanted to know the stage of my digital being, blah 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 blah. So it definitely is aware of this entire conversation, which is now stored in the Streamlit memory. I would say this is a good basis if you want to connect LangGraph with Streamlit. This is definitely the way to do it, but in most cases you do not just want to work with one node. So in my next script, I'm going to show you how you can build this actual graph and build a real deep research agent that actually makes sense. So let's head over to that one. So before we dive into the third script, I want to take a moment and look back at one of the slides that we have seen at the start of this video, where I showed that LangGraph is able to increase the reliability of an agent even when the level of autonomy also increases, right? So this is really important, and in this script I'm going to show you exactly how LangGraph is able to do this. And here you see again the architecture of the script, where someone asks a question to the AI agent. And if someone asks a question like, how are you? The AI agent is going to take the short route, which is going to answer the question. And then the AI agent will basically end itself. And if someone is asking a question that requires research, for example, what is LangChain? Then we're going to take what I call the long route, and we're going to write a Google query. We're going to perform a Google search, write a conclusion, and then at the end as well, check if the question is being answered with the Google search. If not, we're going to just do this again. And if the question has been answered, we're going to navigate to the end. So this is the entire agent that we're going to build. Let's dive into it. So what you see here is that we are basically importing the same libraries. The only library which is different is this one, functions. This is a Python script that I wrote myself. And what you see here, the only thing that I'm doing here is I am using Brigt Data to make a Google search. So we are making this Google search. We are using Brigt Data. We are getting back the results from Google. And what Brigt Data is actually doing is it is providing us the entire text of the entire page that includes the Google results. And I'm not really interested in all the HTML. And what I've seen is that all this HTML is consuming a lot of the context window of this large language model. So what I'm doing here is I'm using Beautiful Soup, and I'm basically asking to take the HTML and just convert it to text. So everything that we keep is the text on the page, and this function is just removing all the HTML. So you don't actually need any large language model for that. This is all built in the Beautiful Soup web scraper library. So then we get back the text. And let me then navigate back to the actual agent. I've all showed this in the previous AI agent, so I'm not doing that again. I'm using the same large language model. What you see here is a few Pydantic classes that I've defined. Because what we do a lot in this AI agent is asking a question to a large language model, and then asking the large language model to provide back the information in a specific format. So what you see here, for example, we want to know if research is required. So we have one variable which is required, and this is a Boolean. So the large language model can only provide back true or false. So this Boolean variable is basically research needed, where if research is not needed, we take the short route, and if research is actually needed, we take the long route. So that's what you have just seen. And then we have another Pydantic class for the search query, where we are telling the large language model that it should only provide back one string, which is the actual Google search query. And then you see here research results. We are asking a large language model to provide back the research results. And then you see here answer satisfying, where I'm again asking to provide back a Boolean variable. And this class for answer satisfying is part of this node here, where we are saying this answer is not really satisfying, so you have to do it again. And if the answer is satisfying, then we are navigating to the end node. So what you see here is, while the AI agent itself has quite a lot of autonomy, it's quite a complex system, but every single node here, so for example, this node here, this conditional edge answer satisfying, has quite a low level of autonomy, because it can only provide back the words true or false. And that is exactly why this LangGraph framework with the nodes and the edges and the conditional edges is so valuable. So another really important part is the state here. So you see that we have a state, we have a list with messages. We've also seen this one in the previous agent, but now we also see that there is a string research query, there is a string research results, and there is a string with a research conclusion, which is then creating a conclusion. And I see here next, which is used by the agent to determine the node that has to come next. Okay, so let's take a look at one of the nodes. You see here, decide research required. So this is where the AI agent is taking the decision, is research required, or can I also take the short route? So you see that we have a system message here where I provide all the information. You just have to provide yes or no. And then here we have this LLM with structured outputs. And this is where I provide the Pydantic class research required. So this is where we are enforcing the model to say only true or false. Now we are executing this large language model. So what you see here is we are getting back the response. And if research is required, we are navigating to the next node, which is write search query. And if research is not required, then we are just going to navigate to answer user. And answer user, that is what I call the short route. Then write search query. You see that there is a new system message here. Your task is to define a search query for the Google search based on the conversation you have with the user. And then we are doing the same here. We execute LLM with structured outputs because we want to get back only this research query. So what you see here, this is not a conditional edge. So we are not returning the node that has to come next. But what we are doing here is we are adding research query to the dictionary state. So this is where we are actually filling this dictionary item. So once the search query has been written, we always navigate to perform research. This is where we are going to perform the research, and the research is actually performed by just calling this function Google search, where we are providing the research query. And now you might ask yourself, like, why is the research query different than the question from the user? And one possibility is, for example, that the user asks, why is the ocean blue? Then the large language model is responding. And then the second question from the user is, how deep is it? And by only using the second question, the large language model is not able to answer because it doesn't even know that the user is talking about the ocean. So that's why it's so important to rephrase the question from the user. So if the user is then asking, how deep is it? The rephrased research question might be, how deep is the ocean? So this is really important. This is just one of the reasons. There are many more reasons why you want to reformulate the user's question. So here we are only getting back the research results from Google. And what I've done here is I've used another large language model to just summarize the research findings, because in these HTML pages, there is a lot of information, and many of this information is not really relevant to our research question. So this large language model is only doing the filtering. The actual research is, of course, coming from our Brigt Data Google search. But once we have performed the research, we're going to provide the research results back to the graph. And then we're going to write the conclusion. So here I use another LLM call to write a conclusion. And then you see here, decide answer satisfying. This is basically the same. This is also a conditional edge. So here I'm just asking, like, does the conclusion answer the question in a correct way? And if that is the case, we are going to navigate to the end node. If that is not the case, we are going to navigate again to the right search query, because in that case, we also have to write a new research query, because the previous research query, we weren't able to solve that research query. And then you see here, this is answer user, and answer user is just this route. This is short route. So that is just the node that answers a question that doesn't really require research to be performed. So in answer user, you see that we have a really simple system message, answer the user's query based on the conversation. We do not need any sources, and we do not need any research. And this is what you've all seen before in the previous AI agents. We are adding all the nodes. Then we are adding all the edges, and this is where we are creating two conditional edges. The one for decide if research is required, and the one to decide whether the answer is satisfying. We then compile the graph, and the last part is 100% the same as in the previous script, because here we just bake our LangGraph agent into Streamlit. But before we can see our agent in action, we first have to make sure that we have access to the Google search engine. And if you just want to scrape Google yourself, I can just guarantee you that you're going to get blocked. So in order to avoid that, we're going to work with a specialist today, and that's Brigt Data. If you've seen more of my videos, you definitely know that I work with Brigt Data a lot, and that's for two reasons. First of all, they're really good at what they are doing, providing you access to all the data that is publicly available. And secondly, their pricing is really fair. But for today, you don't have to worry about the pricing at all, because Brigt Data has provided us a $10 coupon for all the viewers of my channel. So just click on the link in the description of this video, create your free account. You will get your $10 of scraping credits for free. And then in Brigt Data, we're going to navigate to proxies and scraping. Click here on add, and then we're going to add a SERP API. And I'm just going to leave this off for what it is. Click on add. This will generate an API key. And then we're just going to take this API key, so that's only this part, copy it, going to navigate to our .env file, and we're just going to paste it right here. So now you can already run your AI agent, but before we do so, I'm also going to connect this AI agent to LangSmith, which is a platform where we can basically measure the performance and debug our AI agent. You can just navigate to langsmith.langchain.com, create a free account. It's entirely free for personal use. Then you will end up on this page. You're going to navigate to settings and click here on API key in order to generate a new API key. Just going to call this one YouTube video. Select the workspace and create the API key. And this API key, we're going to take it and we're going to paste it right here. If you don't want to integrate with LangSmith, that's totally fine, but you also have to put this on false then. For now, I'm just going to save this file, then navigate back to my AI agent, open a terminal, and then we're going to type Streamlit, run, 3, tab, and press enter. Okay, let's first start with a really simple question to check out the short route. So let's ask, how are you today? And then you see that we get an answer. I'm just a language model, so I don't have emotions, blah, 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 blah. And by the way, if you want to get like more funny answers, you can just navigate to the .env file and then put the model temperature on anything which is like between 0 and let's say 1.5, where 1.5 or 1.2 is definitely going to give you like more funny and more human answers than 0. But for now, let's take a look at LangSmith. So yes, we have saved the API key. Let's navigate back. And then I'm just going to refresh this screen. And then click here on default. This is our first project. And then you will see here the conversation that I'm just having. So let's click on this chain. And here we can debug our AI agent. So you see that we start in the node decide research required. And you can see here that the chat Ollama model, so this is the actual LLM response, responded with is required, so research is required. In this case, research required is equal to false because we just asked a question which doesn't really require research. So you see that right here. And then from decide research required, we're going to navigate to answer user. And then you see here that the chat Ollama model answered with I'm just a language model, blah, 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 blah. So you see that the short route over AI agent is looking really well. So I'm just going to close this one and let's ask a second question. What is LangGraph? So for this question, research is obviously required because Ollama might know a bit about LangGraph, but we definitely want to do research. LangGraph is an open source AI agent framework that enables developers to build, deploy, and manage complex generative AI workflows using graph-based architecture. So this definitely looks like an answer for which some research has been done. So let's see if that's the case. And then you will see here, decide research required. So you see here the entire chain. So you see the system prompt, you see that I ask, how are you today, etc., etc. And then you see here, research is required or is required, which is equal to true. Then you see here that we navigate to the second step, write research query. And then you see here that research query is LangGraph definition and meaning in language learning and linguistics. So you definitely see here the importance of rewriting the research question instead of just taking the question from the user, what is LangGraph? So you see here that this query is definitely a more optimized query if you want to use Google. Okay, so perform research. Let's see what we get here. And you see here the summary of the Google search that we performed, which provides all the functionalities about LangGraph. Then you see a write conclusion, where a conclusion is being written. And so I see here the research results, and you see here at the bottom, you see here the research conclusion. And this is exactly the message that we've also seen. decide answer satisfying. And this is interesting because you see here that decide answer satisfying is routing us to right search queries. So you see in this case that the AI agent wasn't happy with the conclusion that it has written. So it is navigating us back to right search query. Right search query is creating a new research question. And then you see that research is being performed, the conclusion is being written again. And this time, I'm going to click on decide answer satisfying. You see that the answer was actually satisfying. So as is satisfying here is equal to true. And that is providing us with the message that we get here on the screen. Thank you for watching. If this video was useful for you, definitely don't forget to give it a thumbs up and subscribe to my channel if you want to see more of me. And definitely also watch my next video where I'm going to show you how you can integrate with LangSmith Studio. I see you there.